Let's pick up with an example of relative motion from last time. So we have this situation. So a person drops a ball E from a height h at t equal to 0, and another ball B from the same position at t equal to 2 seconds, that is 2 seconds after dropping the ball A. So assuming h, the height is very large, and g is equal to 10 meters per second square, you have to find, first of all, the relative velocity and acceleration of A with respect to B. At t greater than 2 seconds. And from that, find I've already told you, the distance between them at t equal to 3 seconds and t equal to 5 seconds. So all this calculation you do, assuming A has not yet hit the ground. Okay, so just start with this quick sort of revision question from what we've been discussing so far. So this question will combine everything that we've learned, like vertical motion equations as well as relative motion that we've been discussing. So just try this out, people. Okay, so anybody got the answer for the first part? So some students have just joined in. We have just started with an example question based on relative motion that we were discussing last time. So just go through the question and understand it. So what's happening in the diagram and the question is that a person is standing at a certain height, a large height above the ground. And from there, he is first dropping one ball at time t equal to 0, that is ball E. And 2 seconds later, from the same spot, he drops another ball, that is ball B. Okay, so he drops two balls one after the other, one at t equal to 0 and one 2 seconds later at t equal to 2 seconds. So now we have to find the relative velocity and acceleration of ball E with respect to ball B at any time t greater than 2 seconds, and we have to find the distance between them at t equal to 3 seconds and t equal to 5 seconds. So the question is clear to all of you. Yeah, Adinath, the point is the relative velocity will be changing with time. So it will be a function of time. Adinath, your answer of relative acceleration is correct, but the relative velocity will be changing with time. Now, Panna, you have to also understand that. So you take some time, t greater than 2 seconds. Okay. By then, what has happened? E has been in motion for t seconds, and B has been in motion for t minus 2 seconds. Okay. So A will have a downward velocity, which will be gt or 10t, whereas B will be somewhere above it, and it will have a downward velocity of g into t minus 2 because it has been in motion for 2 seconds less. Okay. So take this equation into account and you'll understand how to solve the first part. Yeah, we have just started with this question only. We haven't done anything before this. So just take down the question and start working on it. I haven't explained the whole question yet. No, Bhaumik, your second answer is not correct. Okay, so let's try and understand a little more detail what is happening here. So let's say this is the instant t equal to 0. So the ball A is dropped. Its initial velocity is 0. Okay. Then let us compare this with the instant t equal to 2 seconds. Now this is when he is dropping B. Its initial velocity is 0. So what about E? E will be under him somewhere here. Okay. And it will have a downward velocity by then. So A has been in motion for 2 seconds. So A will have a downward velocity of gt. So that will be 20 meters per second. Okay. And A will have a downward displacement of half gt square. So that will be 20 meters in the downward direction at this instant, t equal to 2 seconds. Okay. Now let us take another instant of time which is more than 2 seconds. So let's take some instant of time, some general instant of time which is greater than 2 seconds. Greater than 2 seconds. Okay. So what has happened is by now the ball B would have moved from here to somewhere here. Okay. So the velocity of the ball B will be how much? It will be g into t minus 2 seconds. For example, if t is 3 seconds, then it's been motion for only 1 second. It will be g into 1. If it is 5 seconds, it will be g into 3 seconds because B has been in motion the only 4. And similarly, B's downward displacement by then, the downward direction, will be half g into t minus 2 whole square. Okay. But by now, E will be somewhere here, further down. Okay. And this whole thing will be half square. Okay, so hope this is clear. Just sharing the screen again. Yeah. So just compare the instant t equal to 0. Okay, when A is dropped with the instant t equal to 2 seconds when B is dropped. Okay. And here A has been in motion, okay, or has been in free fall for 2 seconds. And now compare this with the third diagram where we're looking at time t in general, which is greater than 2 seconds. So A has been in motion or A has been in free fall for t seconds because it started at t equal to 0. Whereas B has been in free fall for delta t equal to t minus 2 seconds. Because this motion started at t equal to 2. So it has been in free fall only for t minus 2 seconds. So just take down this diagram and make sure all the terms in this are clear first. Delta t is the change in time. So for how much time it has been in motion? It has been in motion for the change in time of t minus 2 seconds. It started the motion at 2, and at some time t, the amount of time which has passed or the change in time is t minus 2. The third diagram, you are assuming that the time is now greater than 2 seconds. Okay, so B has, compare the second diagram to the third diagram. B कितने देर के लिए गिरा है? B has been in free fall for t minus 2 seconds. How can ball A have uniform speed? Yeah, both the balls are falling under gravity, so they have a uniform acceleration of g. Both ball A and ball B are falling under gravity, so they have a uniform acceleration of g. Okay. So let's understand this again. So what is happening is that at some time t greater than 2 seconds, okay, now ball A had started from here at t equal to 0 with initial velocity equal to 0. So it went down and it reached somewhere here where the velocity of ball A is this much and the displacement is this much. Now how we solve for motion under gravity? Free fall में क्या होता है? Initial velocity 0 होता है and acceleration होता है g in the downward direction. So use the equation v is equal to u plus at. So the velocity at some time becomes how much? Gt in the downward direction. And for displacement, use the equation s is equal to ut plus half at square. So the displacement under gravity becomes how much? Half gt square in the downward direction. Okay. So these are the equations that we use for free fall. So A का क्या हुआ है? A has been in free fall from t equal to 0 to t equal to t, like this. So what about the velocity of A? It will be gt, and the displacement of A will be half gt square downwards. This is clear to all of you. This is where A is located now at this time t. Okay. Now forget about A for a moment. Now just think about B. So for B, what is happening? B was dropped at t equal to 2 seconds. Okay. At t equal to 2 seconds, B was dropped. So its motion starts. Okay. Again, it starts with initial velocity 0 and acceleration equal to g downwards. So now after some time, at some time t, obviously t is greater than 2 seconds. Like t might be 3 seconds or 4 seconds or whatever. B is located below where what is happening now? At t, B has been in motion for how much time? For time equal to t minus 2 seconds. So for example, if I look at t equal to 3 seconds, delta t for B is how much? 1 second. It's been in motion for 1 second. If I look at t equal to 4 seconds, the time for B is how much? It is only 2 seconds because its motion didn't start at t equal to 0. Its motion started at t equal to 2 seconds. Okay. So velocity of B will become how much? It will become g into delta t because it's moved for that many seconds downwards. And displacement of B will be how much? Half g into delta t ka square downwards. Is this clear now? Yes, so it will always be 2 seconds less, now because वो 2 seconds बाद start किया है. So by the time 20 seconds have passed, A has moved for 20 seconds, but B has moved only for 18 seconds. By the time 25 seconds has gone, A has moved for 25 seconds, but B has moved for how much? Only 23 seconds. So there's always that gap of 2 seconds between how much time A has moved and how much time B has moved. Okay, so I hope this is clear now. So now when you compare the two, you'll realize that now E was dropped from here at t equal to 0. E is dropped. So it has reached somewhere below, like this, with a velocity dA at time t equal to t and a displacement SA. So velocity of A at that time is gt or 10t, and displacement of A is half gt square or 5t square. Okay. Whereas what about B? B was dropped at t equal to 2 seconds. So by the time it is now time t, B is not that far below. It's a little less. B is over here at time t with a displacement SB. So B's velocity at that point of time is how much? G delta t, or 10 into t minus 2. Okay. And B's displacement is how much? Half G delta t square. So it is 5 into t minus 2 whole square. Okay. So this is what A's displacement is, and this is what B's displacement is. This is what A's velocity is. Okay. But both A and B have an acceleration equal to g downwards. So they have same acceleration. They have different velocities, they have different displacements, but they have the same acceleration. Delta means change. Okay, I don't know why this is creating so much problem. The quantity delta, okay, it is read as change in. So if we say delta S, it means change in S. If we say delta T, it means change in T. If we say delta X, it means change in X. Okay, so if we are saying X1 is 5 and X2 is 20, delta X is X2 minus X1, that is 15. Okay, if we are saying T1 is 2 seconds and T2 is 10 seconds, it means delta T is T2 minus T1, which is equal to 8 seconds. Okay, so I hope everybody who is having difficulty understanding the quantity delta, it is clear now finally. Now let's come back to the question and understand this. Yes, Aparna, your answers are correct now for the second part. Bhaumik, have you calculated the second part? Okay. So people, I hope these equations are clear to all of you. Velocity of A and displacement of A and velocity of B and displacement of B, how we have got these 10 into t minus 2 and 5 into t minus 2 whole square. This is clear, right? Because we are taking the acceleration due to gravity value as 10 meters per second square. Okay, good. So now you have to just apply the formula of relative motion. So let's just come to that quickly. You have to apply the formula of relative motion, alright, so let's come back to the question. So the first thing I asked you to do is that for any time greater than 2 seconds, wanted to find velocity of A with respect to B. So for this, we'll have to first define an axis. So we'll define our axis downward as positive because both of them are going like this. Okay. So velocity of A was gt or it was 10t downwards. Velocity of B was g into t minus 2 or 10 into t minus 2 downwards. So velocity of A with respect to B according to the formula becomes how much? VA minus VB. So that means it remains constant. It remains 20 meters per second downwards. And we'll understand in a moment why it remains constant. But you can also get this by examples, for example, that at t equal to 2 seconds, B was at rest. It has just started from initial velocity 0. And by then A would have a velocity of 20 meters per second. Because A's velocity would have been 10 into 2 gt. So it would have been 20. So you can see the relative velocity of A with respect to B is 20. Now by the time it's t equal to 3 seconds, see what happens. B has been in motion for 1 second. So B is now somewhere here and it has a velocity of 10 meters per second because its delta t is how much? 1 second. But by then A is somewhere below and A's velocity has increased to how much? It has increased to 30 meters per second because A has been in motion for 3 seconds. Similarly, by the time it's say t equal to 5 seconds, by now what has happened? B has been in motion for 3 seconds. So velocity of B would have increased to 30 meters per second. But by now A is been in motion for 5 seconds. So velocity of A would have increased and would have become 50 meters per second. But if you keep tracking this at any instant of time, you can see the difference of their velocities is only 20. Now here it is 20 minus 0, here it is 30 minus 10, there it is 50 minus 30. Okay, so like that. So that's why the relative velocity remains constant. That's one way to understand why the relative velocity remains constant. So this is the first thing. Okay. Now similarly, acceleration of A with respect to B. That was the other thing you were supposed to find out. So acceleration of A was g downwards. Acceleration of B was also g downwards. So relative acceleration is how much? 0. So it is 0. So that's another way to understand why relative velocity is independent of time. Okay. That is why the relative velocity is constant or uniform at a value of 20 meters per second. Okay, so hope this is clear. Just make a note of this first. Okay, so everything is now based on these equations actually. So hope you have understood this. Now, once you got velocity of A and velocity of B, these two terms, from this only we are getting the relative velocity, Harshul. The relative velocity of A is defined with respect to B as VA minus VB. So A's velocity is 10t, B's velocity is 10 into t minus 2. So you subtract these two quantities. That's how we get it as 20. Just substitute this value of VA and VB over here. Substitute these two here. That's how we'll get 20. Okay. And similarly, relative acceleration is 0 for this reason. Because they have the same value of acceleration, 10 meters per second square downwards and 10 meters per second square downwards. So their relative acceleration is the difference of the acceleration, so that becomes 0. And because that difference is 0, that is why the relative velocity is constant. Now we have to find next part, the distance between them. We have to find the distance between them at t equal to 3 seconds. So if A has moved to here through a displacement of SA and B has moved from the beginning point to here to a displacement SB. So this is the distance between them we have to find, let's say. We are calling that D. So that D. So that D will be equal to nothing but displacement of A minus displacement of B. So at t equal to 3 seconds, displacement of A is how much? Half gt square or 5 into 3 square. So 45 meters. But displacement of B is how much? Half g into t minus 2 square. So that is 5 into 1 square. So 5 meters. Okay. So that means what is the displacement between A and B, or the distance between A and B at that point of time? 45 meters minus 5 meters. So it is exactly 40 meters at t equal to 3 seconds. Understood? Now I have to just repeat this calculation for the second thing for at 5 seconds. Yes, Adinath, that is correct. Harshul, there is no such thing as total time. There are individual times for which A and B has moved. Yes, Dhyaneshwar, that's correct. Harshul, pay attention. I have given two particular values of time at which you have to calculate the distance between them. One is when it is 3 seconds. The other is when it is 5 seconds. So in the equations, you will substitute t as 3 for the A part, and you will substitute t as 5 for the B part. So similarly, for the B part, at t equal to 5 seconds, the displacement of E is this much. It is 5 into 5 square. So it's 125 meters. Whereas the displacement of B That's 45 meters downwards and downwards. So the distance between them is very simple. It's just this, and that is nothing but 80 meters. So the gap between them increases from 40 meters to 80 meters from t equal to 3 to t equal to 5 seconds. Okay, so this was about our revision question. Now, one more thing you can just interpret over here. See, what is happening is that relative velocity of A with respect to B is 20 meters per second. That means A is moving away from B at the rate of 20 meters per second. Okay. So that is why if the distance was 40 meters at t equal to 3 seconds, okay, at t equal to 5 seconds, the distance should have become 40 meters plus that relative velocity multiplied by the time, which is 2 seconds. Because from 3 to 5 seconds, another 2 seconds has gone. You can see it is 40 plus 20 into 2. So no wonder it makes sense that it should become 80 meters. So how this is increased from 40 to 80? It is increased because every second the distance between them is increasing by a factor of 20 meters. Relative velocity is 20 meters per second. So it's increasing at the rate of 20 meters. Correct. Okay. So hope this is completely clear now, people. All right. So this completes our examples of relative motion. And now we'll be moving on to something which has more application in physics overall. So we'll be understanding the difference between scalar quantities and vector quantities. Just a moment. Yes, Harshul, you have a message. What you did for ET, can you show once again? Okay. Just a moment, people, just for the sake of the students, we will just go through this solution one more time. Now, people, are you familiar with the basics of trigonometry? Like what is sine theta, cos theta, tan theta? Can some of you just reply in message with yes or no? Like, no, not familiar with trigonometry? Okay, okay, got it. So some of you are familiar, some of you are not familiar. Okay, so it's fine, doesn't matter. Okay, so we come to the next thing, which is basically about what we call vectors. Okay, scalars and vectors. So we understand that all physical quantities are divided into two categories. Okay, so in physics, all physical quantities are classified as either scalars or as vectors. So on what basis this classification is done? Scalar quantities are quantities which have only magnitude and no direction. So they are quantities having only magnitude and no direction. Whereas vectors are quantities which have both magnitude and direction. Magnitude means amount. Okay. So we'll understand with examples. Okay. And even before that, what do we mean by the term physical quantity? A physical quantity is any quantity that can be measured. That is any quantity that can be measured. That is called a physical quantity. So on the basis of this, for example, there are quantities that cannot be measured. Like you can say that the amount of happiness or sadness we can't really measure in that sense. But when we talk about the volume, or we talk about mass, or we talk about velocity or speed or anything like that, these are quantities that can be measured. Okay. So they come in the category of physical quantities. Charge, current, electric field, force, etc. These are all quantities which can be measured. So they are called physical quantities. So just make a note of this definition first, then we'll understand what is the meaning of having magnitude and direction versus having only magnitude. So in this, magnitude means the amount or quantity so it is always expressed in terms of a unit, expressed in terms of a standard unit. Yes, Dhaneshwar, that is correct. And see, speed is a scalar, but velocity on the other hand is a vector quantity. So for example, mass is a scalar quantity. We always express like the mass is 5 kilograms or the mass is 200 grams. So this is just a magnitude. It's a magnitude. Okay. Similarly, distance traveled, it is a scalar quantity because it is the total path length. Okay. So for example, if something has gone along this path, it has gone 3 meters like this and 4 meters like this from the point A to B. So the distance from A to D via the path shown is 7 meters. Is the total path length traveled. So distance is also a scalar quantity, and this is nothing but just a magnitude. But for example, we talk about displacement. Now displacement is defined as what? It is the shortest path, or in other words, the straight line pointing from the initial position to the final position. So because it is a quantity that points from a specific point to another point, it becomes a vector quantity. So it becomes a vector. Okay, so for example, we say that displacement is 20 kilometers towards east, let's say. So what that will mean is that suppose something has moved from here to here through a displacement of 20 kilometers. So that is the shortest path or the straight line pointing from the initial position to the final position of east. Then we'll say that the displacement is 20 kilometers. Now it may well happen that the actual path might be like this. Suppose this is the actual path. So you can see that the actual distance is definitely greater than 20 kilometers. Because this total path length is okay, but still we'll say that the displacement is how much? It is 20 kilometers towards east. So that is why when we are describing the displacement, we have to give information both about magnitude and direction. Okay. So when we are saying this is giving information about magnitude of displacement, and this is giving information about direction. So the quantity displacement is defined in such a way that it has got both magnitude and direction. So therefore it becomes what kind of quantity? It becomes a vector quantity. Okay. So just make a note of these 2 or 3 examples. Then we'll discuss more about vectors and scalars. Yeah, but depending on what kind of path we are going by, we might have to use Pythagoras theorem, we might have to use any other geometrical kind of relationship. Yes, Harshul, that is correct. When the object moves along a straight line, then distance and displacement are the same. Yes, I'll show you the definition of vector quantities. Not to go, so don't worry. A lot of things to discuss before it becomes 100% clear what is the difference between vector and scalar. Yes, the way displacement is defined. Okay, Advait, see the way displacement is defined. It is the straight line pointing from the initial position to the final position. So it has to be always along a straight line. It has to be. It's defined in that way. Yeah, I was just saying that the way displacement is defined, it has to be a straight line. Displacement is defined as the straight line pointing from the initial position to the final position. Okay. Now let us understand with examples why vectors and scalars are treated in a different manner and why distance, for example, is a scalar and displacement is a vector quantity. Let's try to understand that. So scalars have only magnitude. they don't have direction. Let's understand this with an example. Okay. So why is this the case? Let's understand. So let's take example 1. Let's take the example of volume. Volume is a scalar. Now, let us say I have a container which has 30 milliliters of water. Now, another 20 milliliters of water are added. So what is the final volume? So what is the final volume going to be? Obviously, the final volume is going to be the initial volume plus the amount of volume added. So it is going to be 50 milliliter. Okay. Now, does this matter from what direction volume is added? Okay. Is this affected by any direction? Like for example, in one case, we might add the volume directly from the top by putting a pipe like this. Another case, we might put a pipe on the side and add the volume like this. Another case, we might drill a hole and use a pump to add water from below. But is it affected by direction? No, it's not affected by direction. Okay. So that is what is telling us that the quantity volume does not have any directional property. And that is why it is a scalar. Okay, understood the point. Okay. Now let's take another example. So this is a distance, okay, A to B of, let's say, 12 kilometers. Okay. And then distance B to C is another 5 kilometers. Okay. Whereas if you take an alternate path, go here, distance B to E is, let's say, again 5 kilometers. Now, runner Amit, okay, let's say, starts from E along path AB, okay, reaches B, okay, and then takes path BC to reach the point C. Whereas runner Rashmi, let's say, also starts from E along path AB. Okay. Then let's say reaches B and then takes path BE and reaches E. Okay. So you have to find the total distance covered by Amit and Rashmi. So again, you will understand in this why distance is a scalar quantity. If you just think about how to do the calculation of this question, you will understand why distance is a scalar quantity. Okay, this is the overhead view. Yeah, I'm showing the question one more time. Both are 17 kilometers upon, right? Okay, both travel 17 kilometers and there is no relation with direction. Okay. Rashmi has reached somewhere here now. Okay. And Amit would have reached somewhere here. But it makes no difference at all. Okay. Both will have a distance traveled of 17 kilometers. Okay. So yes, so all of you understand that here both answers are 17. So again, you can see that distance does not have any defined direction. Okay. Now let's come to a quantity where we are dealing with a vector. Okay, so this is clear to all of you, these two examples. Now next example, let's say okay, Jay and Kushal are both present like this. Now what Jay does is that he goes through a displacement of 3 kilometers here first, and then through a displacement of 4 kilometers and reaches here. So this is how J moves. Okay. Whereas what Kushal does is that he goes through this kind of a path and reaches here after covering 7 kilometers. Find the distances traveled by J and Kushal. Okay. And find the displacements of J and Kushal. And now let us say when I place my compass is like this. This is the north direction and this is the east direction. So this is east. This is north. So you can see that the displacement for Kushal will be directly this. Whereas the displacement for J will be directly this. So by Pythagoras theorem, you can see that both travel a distance of 7 kilometers, but displacement for j equals 5 kilometers somewhere towards northwest. I am saying somewhere because I don't know the angle. This particular line, if I know this angle, then I can say at what angle he travels. So when I say somewhere towards northwest, I mean at some theta angle north of west. Okay. So the displacement, it has a magnitude, which is 5 kilometers, and it has a direction, which is some theta north of west. We haven't found that theta exactly, it doesn't matter. But for Kushal, displacement is 7 kilometers towards east. Okay. Now, yes, the point is, see, you have to mention the direction also. Without that, your definition of displacement is incomplete. Okay. Without defining the direction, without mentioning the direction, my displacement's answer is incomplete. Now you'll understand with my next example even more clearly why the answer is incomplete without the direction. So why is direction so important when defining a vector? Let's understand that thing. Why is the direction important in the definition of a vector? Let's understand this with a couple of examples. In this example, I tell you that a particle makes a displacement of 10 kilometers towards east, okay, from 12 to 12:30 p.m. 12 noon to 12:30 p.m. Okay. And then a further displacement of, let us say, 10√2 kilometers from, or let's just say 10 kilometers, doesn't matter, why to complicate things. displacement of 10 kilometers, whatever, 12 kilometers from 12:30 to 1 p.m. Okay. Find its net displacement from 12 noon to 1 p.m. Okay. Now just try to visualize this problem. How we will handle this. Just think of it. How much should be the net displacement? Okay, so what is happening in this problem is we cannot find the net displacement. Okay, because that's exactly the thing. See, the second displacement that is happening, this one of 12 kilometers, what about its direction? If we don't know the direction, without that information, we cannot calculate the net displacement. We cannot find this. Okay. Because direction is unknown. Whereas, for example, suppose in the same problem, okay, suppose in case A, the 12 kilometers displacement from t equal to 12:30 to 1 p.m. was towards west. Then what about the net displacement? Yes, very good. The net displacement would have become 2 kilometers towards west. So then we would have seen that whatever first displacement is making, starting from some point, he's going from here to here, let's say. So this is what his initial position was at t equal to 12 noon. When he reaches somewhere here at t equal to 12:30 p.m. Okay, so this is his first displacement. This is 10 kilometers towards east. Okay, so this is 10 kilometers. Then from this point, he would have made a displacement and reach somewhere here at 1 p.m. So this second displacement, 12 kilometers towards west. So his net displacement now would have been this arrow. His net displacement would have become this arrow. Okay. So that is why his net displacement is 2 kilometers west, okay, from 12 to 1 p.m. So now you understand the importance of direction, why the information about displacement is incomplete if I don't know the direction. Okay, so the whole point is that I cannot define without direction. Suppose we take a case where 12 kilometers from 12:30 to 1 was towards south. Okay, now tell what will be the net displacement. Yes, you'll have to use Pythagoras theorem. Correct, Drew. It will be something like that. So in this case now how the diagram will look like that. He first went 10 kilometers in this direction towards east, and then he turned 90 degrees and made a displacement of 12 kilometers towards south. So he reached here at 1 p.m. whereas he started from here at 12 p.m. So his net displacement is now going to be this one. This is the net displacement. So it's going to have a magnitude of some theta like this. So this will be very close to 12.8 kilometers. Yes, square root of 244 is also correct. Okay, so any of these answers is okay. But the more important thing is the quantity itself. Why it is a vector quantity and not a scalar quantity. So hope this point is clear to all of you. Yeah, you can leave it as root 244. It's fine. So as I said, any of these answers is fine. Okay. Let's see another example. So a person first walks 20 kilometers towards west and then turns 120 degrees towards the northeast, such that he is then at 30 degrees east of north, okay, and runs a further 20 kilometers along this line. That is 30 degrees east of north. So find his net displacement and distance. So just try to make a diagram for this and understand the question first. Then we will come to the calculation. Yes, distance traveled is 40 kilometers, obviously, that's correct. Yeah, Harsh, the first displacement you've written is correct. No, Dhyaneshwar, the displacement is not zero. So let's try to understand this with a proper diagram. Anybody else? Yes, good. Bhaumik, that's correct. So he is first going towards the west with a displacement of 20 kilometers. So this is his S1, let's say, the first displacement. It's towards west. Okay. Then what he does is from here, he makes a turn of 120 degrees. So that now his displacement is pointing towards northeast, like this. So this is his second displacement. Okay. So you can see that his second displacement is such that from north towards east, it is 30 degrees. So the total turn he makes is of 120 degrees, but in the process where he ends up, what angle he ends up traveling at, this is 30 degrees. Okay. So this is 30 degrees east of north. That is that direction. So he goes in this sort of direction. And he travels how much? He travels another 20 kilometers. So now this is his final position. And this was his initial position where he started from. So what is his net displacement? His net displacement is going to be this arrow. This is his net displacement and it is going to be at some kind of angle theta like this. So we have to find that net displacement's magnitude and the angle both. Now distance traveled is obviously 20 plus 20 equal to 40 kilometers. Yes, very good. The thing you have to catch is that this is an equilateral triangle. So how do we stumble upon the fact that it's an equilateral triangle? For that, see what all information was known to us. It is known that this is 20 kilometers, this is 20 kilometers, and this angle is 120. This is the information that is known to us. So from that, what we can now further extrapolate, we can extrapolate that this angle is 60 degrees and this side is equal to this side. So whatever this angle is, this is the same angle theta. So you can see that theta will have to be 180 minus 60 by 2. So it has to be 60 degrees. So therefore, it has to be an equilateral triangle. So that means my net displacement is also 20 kilometers and it is at 60 degrees north of west, because this was north, yeah, this is the west. So you're going theta, because theta is equal to 60. So this becomes my final answer. Yes, because without the direction, your definition of displacement is incomplete. अगर मैं बोलता हूँ कि displacement 20 kilometers है, then it's not the complete definition of displacement. It's just giving you magnitude, not the direction also. Yeah, it is not only 20 kilometers towards northwest, but it is exactly at 60 degrees north of west. That is the complete proper answer. Yes, if it would have been 150 degrees, it wouldn't have been Pythagoras. The displacement would have to be something else. So let's look at a question like that. Now. So next example, what's happening here is a person is making some displacement of 10 kilometers towards east, okay, and then some unknown displacement. But after making a turn of 150 degrees, such that or let's say even 150 is not known. This is some theta. Also unknown. So S1, the first displacement is 10 kilometers towards east. S2 is completely unknown, both in magnitude and direction. But the net displacement is 10 root 3 or approximately 17.32 kilometers towards north. So find the second displacement. Let's in the previous question, we got the angle by the fact that it was a equilateral triangle. That's how we came to know it's 60 degrees. So the answer will be 20 kilometers here. And the angle will be 120 degrees. Or 60 degrees north of west. Okay, so just apply Pythagoras theorem here. Just apply Pythagoras theorem. This is the base and it is equal to 10 kilometers. This is the hypotenuse, which is my S2, which is unknown. And this is the perpendicular, which is 10 root 3, which is the net displacement. This was S1. And this angle is 90. So hypotenuse square is perpendicular square plus base square. So you just use that. So S2 is becoming square root of 10 square plus 10 root 3 whole square. (20 kilometers). S2 is. Now we also wanted to find out this angle theta. So if you take this inner angle as alpha, suppose, so you can see that theta is equal to 180 degrees minus alpha. Okay. And in this triangle, we can see tan alpha is perpendicular upon base. So I'll revise the trigonometric ratios concepts for you in just a moment. Okay. So here tan alpha will become root 3. So that will tell us that alpha is equal to 60 degrees, which means that theta is equal to 120 degrees. Okay. So you can see that S2 is a displacement of 20 kilometers at 60 degrees north of west, because S2 is like this. This angle is 60 degrees and this is north, this is west. So that is the complete solution of this. You just make a note of this. So if you're not familiar with that tan alpha term, don't worry, I will do a revision of trigonometry, or the basics of trigonometry I'll explain to you. So the full answer is now like this. Yes, that is correct, Daniel. See this 10 root 3 whole square that we are doing, that is 10 square into root 3 to the power 2. That is 100 into 3. So that's how this term is becoming 300. Okay, Vyom, I'll take you back to the previous question. No worry. First, note down this one. Yes, I will explain the trigonometry part, tan alpha part only. That is trigonometry. I'll explain it to you. If you're not familiar with this, tan alpha is equal to perpendicular upon base, then don't worry about it just now. I'll explain it to you in detail. Okay, so just because Bloom has asked me, I'm taking back to the previous question. There it was something else altogether. So in the previous question, Bloom, what was happening? These two are 20 kilometers. So this was 20 kilometers and this was 20 kilometers. So this angle became equal to this angle. So that's why these two angles are becoming equal. And then once these two angles were equal, now we knew that this angle is 120. So this interior angle was how much? 60 degrees. So we know that 2 theta plus 60 is equal to 180. So that's how we got from here that theta is 60. And that's how we got that it's an equilateral. Okay, so that was the trick over here. Understood, you? Okay. Now in this one, for the angle part, we have just used a mathematical fact which is called trigonometric ratios. So I'll do a quick revision of trigonometric ratios concept. So trigonometric ratios, they are defined for any right angle triangle. So we have a right angle triangle such that this is the right angle and this particular angle is denoted by theta. This is the hypotenuse, this is the perpendicular, and this is the base. So whichever angle we are considering, like here we are considering the angle theta. So for the angle theta, that side opposite to it is called the perpendicular. Or you can also call it the height of the triangle. The side along which it lies, that is called the base. And the angle between the perpendicular and the base is 90 degrees. And H is called the hypotenuse. So the angle between the perpendicular and base equals to 90 degrees. Whereas the angle between the base and hypotenuse, that is theta. And obviously the other angle is therefore 90 minus theta. Now for such a triangle, there is a certain relationship between the sides, and that relationship is always a function of theta. Okay, so the ratios of side lengths, that depends on the value of theta. So for example, if the perpendicular's length is equal to the base's length, or in other words, perpendicular upon base is 1:1, then we know that theta is how much? Theta is 45 degrees. Is the case of the isosceles right angle triangle. That will be a triangle that looks like this. If this side is equal to this side, then this angle is equal to this angle, and that becomes how much? It becomes 45 degrees. But on the other hand, if the angle is less than 45, then you can see the perpendicular will be longer than the base. If the angle is less than 45, you will see the perpendicular will be shorter than the base. Okay. So you can see the ratio of all these sides, it just depends on the angle. So that is what we mean by saying that the ratio of the side lengths, these ratios, actually depends on the value of theta. And that is what is called trigonometric ratios. Okay. The ratio of perpendicular upon hypotenuse is called sine theta. It is defined by a term called sine theta. It is read as sine theta. The ratio of base upon hypotenuse is read as cos of theta, or it is also read cos theta or cosine theta. And perpendicular upon base is defined by a quantity tan theta, which is simply read as tan of theta. So these are the definitions of my three trigonometric functions, sine, cos, and tan. Especially if you're new to trigonometry, just make a note of this first. Just a moment, I will restart this. Just hang on a second. Okay, so just make a note of this. Yeah, Dhaneshwar will start projectile motion in the next lecture. Yeah, Bhumika, I'm coming. Okay, so now let us just quickly look through some common values. So trigonometric ratios for common right angle triangles. So the first one is obviously the most trivial one we were discussing about, the isosceles right angle triangle. So this angle is 45 degrees. Then perpendicular is equal to base, and the hypotenuse becomes root 2 times the perpendicular, or root 2 times the base. So we have sine 45 is equal to 1 by root 2. Cos 45 is equal to 1 by root 2. And tan 45 is equal to 1. So this is the first of the common type of triangles. Theta equal to 45 degrees. Next, we'll see the case of theta equal to 30 degrees. So that is a triangle that looks something like this. Where you can see the perpendicular is smaller than the base, because this angle is 30 degrees. So this triangle is getting somewhat squashed like this. So here, by definition, what happens is sine 30 degrees comes out to be half. Cos 30 degrees comes out to be root 3 by 2. And tan 30 degrees comes out to be 1 by root. So for example, in your class 10 trigonometry, this will be important for you to remember these values. Yes, tan 30 is 1 by root. I mean, there's nothing to scold. This is the only thing we have written so far. Yes, these are fixed values. So whenever we have a 30-degree right angle triangle like this, the ratio of perpendicular to base will be 1 by 1. Yes, tan 45 is 1. Because perpendicular base ratio is unity. See, tan theta kya hota hai? It is the ratio of perpendicular upon base. So here they are equal. The perpendicular is equal to base. So that's why it's unity. Sin theta kya hota hai? It is perpendicular upon hypotenuse. Cos theta kya hota hai? It is base upon hypotenuse. Yeah, so for different values you have different ratios, but you cannot memorize all of them. For that you have a separate thing called a table. You have sine, cos, tan tables, just like you have your log tables. Okay. But there are some common values that you have to remember. So two of them are this, and the third one is the 60-degree triangle. If this is 60 degrees, then sine 60 becomes root 3 by 2. Cos 60 becomes half. And tan 60 becomes. So notice something very interesting over here, that sine 60 has the same value that over there cos 13, and cos 60 has the same value over there that sine 13, and tan 60 is nothing but 1 upon tan 30. Now there's a reason why this is happening, and we'll discuss that also. Yeah, you can find it on the internet. It's not such a big deal. Like you buy logarithmic table, or you can find any table on the internet. Just Google it, you'll find it. Yes, tan 60 is equal to root. So these are the three special cases of the right angle triangle, which you should remember for the moment. Okay? You don't need to worry about other random values like 35 degrees or 15 degrees or 20 degrees or things like that. No, then nobody will be able to see moment. So I'll give you time, don't worry, to write down all three together. Give you time. Okay. Now it is for you to find out exactly what is the logic of this relationship, why this is happening. Okay, this you will try to find out yourself why this happens. Okay. In the meantime, we'll do a quick question now based on this. Okay. Now our next example is like this, that a person makes a displacement of 10 kilometers towards east, and then makes a displacement of some S2, but after turning like this through 150 degrees. Okay. Now as a result of that, his net displacement is becoming like this. Okay. So now we have to find S2's magnitude such that the net displacement is towards north. Okay. And also find the magnitude of S net. How much the net displacement is. Okay. As usual, our north, south, east, west directions are like this. Okay. So this is towards east, and this one is towards north. Let's try this out now. A very simple application of bombing. Just another 2 minutes I'll take, don't worry. No, Dhyaneshwar, or rather Devanshu, that is not correct. Sin theta is not 1 upon cos theta. There's no relation for that. Yes, very good. So what we'll have to understand here is that this is a right angle triangle where theta is equal to 30 degrees. We'll have to use the value that cos 30 degrees was how much? Root 3 by 2. And that was base upon hypotenuse. Okay. So in this case, what is the base? It is S1, and what is the hypotenuse? It is S2. So root 3 by 2 equals S1, which is 10 kilometers, divided by S2, which was unknown. So So this tells me that S2 is equal to how much? 20 root 3. 20 divided by. Okay. And I also know that tan 30 degrees is 1 by root 3, which is nothing but perpendicular upon base. So that is over here nothing but net displacement divided by S1. So net displacement is becoming 10 by root 3 kilograms. So these becomes the answers to this question. Using trigonometry, this becomes the answers. So that is the purpose of trigonometry, that once we know the values of these ratios for the known angles, we can do any calculation related to vectors. Okay, that is why trigonometry is important in our application of vectors later on. Okay, people, so hope this is clear, and that's it for today's lecture. अगर ये 150 की जगह 120 होता, then this angle would have been 60, then it would have been something else. Okay, but here because this is 150, so this inner angle is 30, so we have to make use of which values? Cos 30's value and tan 30's value, which we know from before is that much. Yes, Vyom, tell me. No, Dhaneshwar, that is not the correct answer, that it is double of, that's why it becomes like that. The hint to you is that just look at the two triangles, the one which had 30 degrees and the other one which had 60 degrees. You'll realize that it's the same triangle, but it's just kept in a different way. Now you can flip it and it will become the other triangle. So that is the hint to you. Okay, I'll discuss in more detail in the next lecture. Okay, yeah, don't worry, I'll send the whiteboard screen to you. Okay. And also hope all of you have received the modules, physics module 1 and 2 PDFs in the WhatsApp group. So keep it downloaded with you, because I'll be giving you some questions to solve from the module. Okay. So I'll be sending you the recording as well as the whiteboard notes, as well as a list of some questions to solve from the module. Okay. That's it for today, people. Okay. Thank you all.